Hello, YouTube. This is UMills03. Now we're on to lesson 32 in the Java curriculum, and this lesson is going to be about polymorphism. And it's closely related to what we talked about in the previous lesson, so I don't think it would hurt to do a little bit of a review of inheritance and talk again about what we have going on here. So remember that in lessons 22 through 24, we were building up a person class, and we said basically we can create our own classes in Java, basically our own data type, and keep track of fields that we think are going to be important throughout the execution of our program. So here we declared two private instance variables, and then we have different types of constructors. We've talked about this several times now, of how having different constructors allows us to basically have the freedom to pass in different sets of inputs, and then the other values that we don't pass in, that we don't specify, would take default values. Okay, so you can see that here, this is a completely default constructor because all the values are default. And then you have two getter methods. So we just have a public method that returns the name instance variable, and then another public instance method, which returns the age of the person object. And then you have setter methods, of course, and so these are void methods. They don't return anything. They just change the values of either name or age, depending on which of the methods you call. And then finally, a toString method. And so we say that if we write the method in this particular way, this is an official method header for a toString method. So you say public string toString, and it allows you to specify what string should be printed, what string should be returned and printed on the console if you try printing a person object. And then what we did is we said, well, we have all the functionality from our person class, but what if we want to create a class that's even more specific, a class that takes all of person's functionality and can have some of its own? So what we did is we investigated this student class. And the way that we created the student class is we wrote extends person up in the class header. And so by doing that, it means that it's going to take all of person's functionality. So if I called the getName method or the getAge method or the setName method or the setAge method or the toString method on a student object, we would know how to do that, even though there are no definitions for those methods in this class because they already exist in the superclass. And but subclasses can also have their own methods. So for example, these are two examples of methods that don't appear in the person class. So what are two things that we can do with the student object that we cannot do with a person object? Well, we could have them study harder, which is sort of a setter method, although instead of just passing in a value and setting GPA equal to it, we call the method with no inputs, and it simply increases the GPA by a constant amount. And then we could also get the GPA. So we could also return the stubble for a student object, but not for a general person object. And then one of the things we said in the previous video is basically what we can do is we can take a superclass's version of a method and edit it in the subclass. So what that means is we have a public string toString method. And we said, well, we already have a toString method from the person class. So why does student need to have a toString method if student is inheriting person's toString method? And what this super.toString method allows us to do is if you call super dot and then a particular method, what it'll do is it'll basically retrieve the superclass's version of that method. So it would return the string that was specified that you said you were going to return in the toString method of person class. But then we see the plus sign here, and we said with strings, this is not a plus sign, it's a concatenation. So what we do is we take the name and then is and then age and then years old. That's how we define the toString method in the person class. And then we go ahead and combine. We go ahead and modify that toString value and add something else onto it. And so we went ahead and saw a couple of examples with that. So now we go into the person tester class. And then if we go ahead and try printing this student object, not only would it say Renee is 16 years old, because that's how we instruct Java to print a person object, but it goes one step farther and it says Anne has a 2.82 GPA because we overrode the toString method. And that's what's called overriding a method. So overriding a method is when you take a method from a superclass and you modify it in a subclass. So that's all that we have going on here, and I want to show you one more example of that. So for example, if we did the student method, let's go back to the student class. Let's go ahead and say, actually, let's do it in the doctor class because we already have an example of how this works for student. But we said that we can have multiple classes extending the same class. So doctor gets to be its own subclass. So doctor and student are not really related to each other, but they're both related to person. They're both sort of examples or special cases of a person. And so we looked at this doctor class and we said that we can have a particular method just for a doctor object that would not apply to a person object, and certainly it wouldn't apply to the student object either. So here we have another field, we have another instance variable that we thought was going to be special for our doctor class uniquely in particular. And so we just have a method that lines up with that. So if we want to return the hospital, which was assigned in the constructor, then we can go ahead and do that just by calling the getHospital method on a particular doctor object. And then I guess the last thing we said in the previous video, what we said a little bit earlier in the video, is the way that the super works for a constructor. So basically, if you have the student class here, what happens is in this constructor, if you say super of NA, what happens is it goes to the superclass. It goes to the superclass and it says, can I find a string? Can I find a constructor that accepts a string and an int? Because we called super of NA. And according to what happened in this constructor header, N is a string and A is an int. So it says, gee, can I go into person and find a constructor that accepts a string and an int? And it's this one. And so it runs this functionality. It copies this functionality. So the name instance variable, that still applies to the student class. Even though name and age were not declared at the top of student, they were already declared in person. And by the virtue of student inheriting person, student gets not only person's methods, but also person's instance variables. And so for this particular student constructor, it would go ahead and assign name to N and age to A, just like was the behavior in person. And then it goes one more, oh, this is for the doctor, but it goes one more step of assigning hospital to H. It just assigns the third instance variable according to whatever the third thing was that the programmer passed in. So hopefully that's clear to you how that works. And then we can go ahead and run the person tester, but hopefully you get an idea, right? Because we went ahead and printed that student object and we got not only person's toString representation, but student's toString representation, which is to start with person's toString representation and then concatenate on and has a, and then whatever the value of their GPA is, and then the word GPA. One of the things I hinted at earlier in previous videos is that every class is a subclass of the object class. So let me show you what I mean by that. Essentially what I'm going to do is I'm just going to pull up a quick API so that I can tell you guys, I can show you guys what I'm talking about here. So essentially what I'm going to do is I'm going to pull up object Java API. So we've already talked about a lot of important classes in Java, right? We've already talked about so many. So string, scanner, math, integer, Boolean, character, double, you know, there's other ones that probably other ones that we've talked about too, array list, right? And so now we're looking at the object class. So object is the root of the class hierarchy. So every class has object as a superclass. So not only is student a subclass of person, but person is a subclass of object. And so if you look down in the documentation for the object class, I think one of the things we brought up previously is this toString method. So if you don't have a toString method in a particular class, it calls the toString method of the superclass of, it calls objects toString method. And so what would that be? It would be an unsigned hexadecimal representation of the hash code of the object. And that's not as helpful, I think, if you're talking about a person object, as saying their name and then is and then age and then years old. So if you had really wanted to write up here, you could have said person extends objects, but that already happens by implication. Person is already taking objects toString method, but then it's sort of rewritten here. It's sort of rewritten. It says, okay, well, instead, I don't want to use the old toString method. So that's why we don't say anything like super.toString, because if we said that, it would reference this would be the hexadecimal representation of the hash code of the object, but that's not helpful for us. So we don't even call on the superclass's toString method. We don't even want it. We just completely rewrite it here. And you could totally do that in one of your subclasses. So let me give you an example. For example, you have the get age, right? Which in the person, which returns a particular person's age. But what you could do is you could come into doctor and you could go ahead and say public int get age. And I'm going to show you another example of calling super on a particular method, because what you do is you could say return super.getAge. And what basically this happens by implication. So if you don't rewrite a method, this is what's happening, is it would just return the superclass's version of a particular method. If it was a void method, instead of saying return super.getAge, it would just be super.getAge. So you'd just be calling the void method. But if it returns an int, then that's what you would be returning. So you could say return super.getAge plus 200. So what does the doctor do? Instead of just using person's getAge method, it uses person's getAge method, but whatever int comes out as a result of that, it's going to add 200 to it. And now what I'm going to do is I'm going to try that out in the person tester. So remember, if we look at the doctor constructor, we have to feed in a string and then an int and then a string. And if you wanted to have other options for that, you certainly could. You would just have to write them in. So what if you just feed in the string and the int? Well, we can assign the name and the age according to how the person's constructor does it. Assigns name to n and age to a. Those are instance variables that are carried over to the subclasses. Doctors have a name and an age too. Students have a name and an age too. And then you could say something default. You could use this optionally. We said you don't need this if there's no confusion between the instance variable name and the parameter name, but you could go ahead and give it a default value. And so this is another example of a constructor. So let's test both of these constructors. So what we're going to do is we're going to say Dr. B equals new doctor, and then for this one we'll just type in their name and their age, and then we could go ahead and say Dr. C equals new doctor, and then let's pass in all three. So let's do Allison, 38, and she's at Stanford Medical. Okay, so then essentially what we can do is we can try printing the results of getAge and making sure that it'll do doctor's version of the getAge method and not just person's. So now if you go ahead and do system.out.println of b.getAge, you wouldn't just be getting that 57 or 52 or whatever it was, but you'd be getting 200 plus that, because we said in doctor, we're going to take the superclass's version of a method and modify it and add 200 to it. And that's totally valid. And you could have just said 200 and then it just returns 200. Then at that point, it doesn't even depend on the original functionality that you wrote in person. It would just return the number 200. So now you go ahead and compile this and you can run it, and now you just get the number 200 there. So it's up to you. You can totally rewrite, redefine methods from a superclass in your subclass. But if you don't, you'll just be using the subclass versions of the method. Okay, so hopefully that's clear to you. And that's essentially what we have going on here. And also that just the idea that you could have two different subclasses for the same method. And then if you don't rewrite a toString method, remember we rewrote the toString method of student by adding on the GPA section and has a particular GPA, but doctor doesn't have its own toString method. So what toString method does doctor use? It uses persons. It uses persons toString method. So it just says Allison is 38 years old. And if you wanted a doctor to also print their hospital, then you would just say public string toString, and then you would go ahead and say, return super.toString, and then you could say and works at, and then just whatever hospital they work at. So now if you go ahead and compile it, hopefully you're getting the idea here. So now we go ahead and test it. We go ahead and print the doctor this time. We're not just going to see Allison is 38 years old. If we run the method, we see Allison is 38 years old and works at Stanford Medical. And if you didn't provide Stanford Medical, it would use the other constructor and it would use the default value instead. So now you go ahead and run it without specifying that, and it says works at Mercy Hospital, because for the constructor that doesn't feed in a hospital, the hospital is assigned by default to Mercy Hospital instead. There's one other topic that we need to talk about. Most of this video has been a review of what was discussed previously, because inheritance is a pretty important topic. But now we have to talk about something called polymorphism. And that's the idea that if you declare an object of a particular superclass, so if you declare an object as a person, but you initialize it as a student or a doctor, you can only use person's functionality. So let me show you what I mean by that. If you do person A equals new doctor, right? And then we can have Allison again, 38, and she's switching hospitals. Now she works at Albuquerque Medical or something like that. I don't know if I spelled that correctly. But what happens is you would not be able to use doctor's unique methods here. You would basically, this A even though it's initialized as a doctor object, it's declared as a person object. So now let's go ahead and try to print a.getHospital because we want to figure out what hospital Allison works at. The problem is it says it can't find the getHospital method because even though you initialized the object as a doctor, you declared it as the superclass. So if you declare an object as belonging to a superclass, it can only use that superclass's methods. Now, if the doctor class modifies one of the methods in the superclass, it will use doctor's version of it, but you cannot call methods that were not defined originally in person. So hopefully that makes sense to you. Yes, it was sort of created as a doctor, but we can't use doctor's specific methods because we declared it as a person object. So the getHospital would be off limits. And then, but what do you think would happen? What toString method would we get if we tried printing this object? Would we get doctor's toString method or would we get person? So now we can go ahead and try that out. But I'm going to show you the solution to this in a second. But what you would do, so we're not going to be able to use getHospital because A was declared as a person, and that's sort of that's why we bring up the topic of polymorphism. So what I'm going to do is I'm just going to try printing this object, which was declared as a person and initialized as a doctor. And so we need to figure out whether or not we're going to see this information about the hospital, because this hospital thing shows up in doctor's toString method, but not in person's toString method. So now if you run person tester, you see Allison is 38 years old and works at Albuquerque Medical. So the note to make here is that if you declare an object as a superclass, but initialize it as a subclass, it can only access the methods that were initially defined in the superclass. However, if the subclass modifies one of those methods, that object will use the subclass's version of the method. So hopefully that's clear to you how that works. So we would use doctor's toString method, but we can't get doctor's unique methods that were not defined in person because this object was declared as a person. The technique to solve that is simply to explicitly cast the object to being a doctor. So here's what you're going to do. You're going to declare a new doctor object. So you declares a doctor object. Okay. Unlike what we did up here. Here we initialized a doctor object, but we never declared a doctor object. And then what you would do is you would say B equals doctor of A. So what this does is it's an implicit cast from a person object to a doctor object. And you're allowed to do that because since the object was initialized as a doctor, you would be able to basically change its declare type. So you would allow B to be declared as the doctor version of A, okay? So what you would do now is you would be able to say system.out.println of b.getHospital, and this would work out because now the item is officially a doctor. So you can use doctor's functionality. You can use methods that appeared not in person, but in doctor. The same thing would happen with student. So for example, the study harder, right? So you could go ahead and declare a person object. So you could say person D equals new student, and we could just go ahead and give them a name, right? Because we built a constructor in the previous video in the student class that just accepts a name, right? And then it would call person's constructor that just accepts a name, you know, and then it gives the age something default and assigns name to N, and then GPA would be 3.2. But anyway, what I'm trying to say here is now, you know, if you say system.out.print, you know, if you say d.studyharder, you would have an issue with this. You would have an issue with this. So now if you compile it, there's an issue. It says, I don't know what you mean by study harder. But then if you say student E equals student of D, and now you go ahead and say E.study harder, then we would be able to see the improved GPA. So now we say E.getGPA, and maybe you remember from when we were looking at the class that it was defaulted to 3.2 under that particular constructor, but now we print 3.3 because the method worked when we changed to the data type. We changed the declare type from person to student, and that's what allowed us to work. So that's called polymorphism. And hopefully that's clear to you, and we'll continue our conversation of object-oriented programming in the next lesson. So from UMills 03, thanks for watching, and please subscribe.